Hello everyone, welcome to Chemspires. In this video, we'll be looking at problem number 7.18 from 11th Standard Chemistry NCERT textbook. The question is, the ionization constant of HF is 3.2 into 10 power minus 4. Calculate the degree of dissociation of HF in its 0.02 molar solution. Calculate the concentration of all species present. H3O plus F minus HF. In the solution, let's solve it. First of all, the following proton transfer reactions are possible. So number 1 and number 2 reactions that are possible are HF plus H2O, which is in equilibrium with H3O plus F minus. And for this, Ka, that is dissociation constant for acid, is equal to 3.2 into 10 power minus 4. And the reaction number 2, H2O plus H2O, that is 2H2O, which is in equilibrium with H3O plus OH minus. This is the dissociation of water itself. Therefore, for this, Kw, that is the equilibrium constant of water, is equal to 1 into 10 power minus 14. From this, it is evident that Ka value is much greater than Kw. So from this, the reaction is HF plus H2O, which is in equilibrium with H3O plus F minus, the first reaction. So the initial concentration is given as 0.02. So initially the concentration of H3O plus and F minus are 0. And here the alpha is the degree of dissociation. So at equilibrium, the concentration of HF will be 0.02, that is initial minus 0.02 alpha, and the product's concentration will be 0.02 alpha and 0.02 alpha respectively. So here the substituting equilibrium concentrations in the equilibrium reaction for principal reaction, it gives, so Ka will be equal to the concentration of the product's power stoichiometric coefficient by product of the reactants raised to the stoichiometric coefficient. So Ka will be equal to 0.02 alpha into 0.02 alpha divided by 0.02 minus 0.02 alpha. It will be equal to 0.02 alpha square by 1 minus alpha, which is equal to 3.2 into 10 power minus 4, which is given in the question, that is Ka. So we obtain the following quadratic equation. What is it? Is alpha square plus 1.6 into 10 power minus 2 alpha minus 1.6 into 10 power minus 2, which is equal to 0. By solving this quadratic equation, we will get two values of the roots, which is plus 0.12 and minus 0.12. The negative root is not acceptable, so we will take alpha, which is equal to 0.12 as the final one. The negative is not acceptable because degree of dissociation cannot be negative. This means that the degree of ionization, that is the degree of dissociation or degree of ionization, which can be said as alpha, is equal to 0.12. Then equilibrium concentration of other species, that is HF, F minus, H3O plus, which are to be found, are concentration of H3O plus is equal to F minus, which is equal to C into alpha. C is the concentration. So 0.02 and alpha is the degree of dissociation, that is 0.12. So the final answer will be 2.4 into 10 power minus 3 molar. And for HF, the concentration would be C into 1 minus alpha, that is C 0.02, and 1 minus alpha is 1 minus 0.12. So solving we will be getting 17.6 into 10 power minus 3 molar. So finally we have to find out the pH of the solution. So we know that pH is equal to minus log H plus. So H plus concentration is 2.4 into 10 power minus 3. This we have found in the previous step, that is H3O plus concentration, right? So we will be writing minus log into 10 power 4 into 10 power minus 3, which is equal to 2.62. This is the final answer of, that is value of pH.